Hi everyone, so today we're going to go over our lesson for solving for surface area. This is just part one of two. There's two more shapes that we're going to be going over next week. But for right now we're going to focus on doing a cube, which was what we discussed in the discussion board yesterday. And we're going to do a rectangular prism as well. So we're going to use nets to help make sense of the formulas that we use to solve for surface area. So first and foremost, so this is a cube. If you were to unpack it, if you were to cut this out of maybe perhaps grid paper, so 6 even squares in this formation, you could actually fold them together. This being the bottom, the sides, and then this last flap, once the side is folded up, can just fold over on the top there. The idea behind surface area is that on a 3D shape we see 6 flat squares, right? Surface area is the total area of all of those flat squares together that make up that 3D shape. So as we discussed in the comments yesterday, the most common formula would be essentially solving for the area of the square. Some people said length times width, which makes sense for a rectangle because length and width are different. On a square, they're the same. So when we do a formula for solving a square, it's actually s to the power of 2, meaning s times itself. So you can see here, every single side is 4. So if we do 4 squared, that would find the area for one of these squares. Now we have 6 equal squares, so that's why we would multiply the area of one of these guys by 6 to get the total surface area. So let's go through the steps. First and foremost, with anything that has to do with formulas and expressions, we have to follow order of operations. So that brings back the idea of bed mass, brackets, exponents, division, multiplication, addition, and subtraction. And that just means that we have to do all of the brackets in the equations before we move on to the exponents. If there's no brackets, then you have to do the exponents. If there's no exponents, then you do the division next, and so forth. You essentially do each one of these things before getting to addition and subtraction if they're applicable in your formula. So the first step for this one is 6, which is the 6 squares, and then I put it in brackets just to separate it because we know that a number beside brackets means multiply. And 4 squared, because s, the side length is 4, and it's to the power of 2 to figure out the area of one of these squares. So we're left with, again, in bed mass, we have to do exponents first, brackets and exponents. So 4 to the power of 2 is 16. So now we're left with 6 times 16. Simply, for the cube, you just throw that in your calculator, or you can do that in your head. 16 times 6 is 96 centimeters squared. So it is centimeters squared because we are still talking about a 2-dimensional area, right? It's just the outside flat surfaces of the cube that we can see. The rectangular prism requires a few more steps, and I find that it can be a little confusing if you don't break it down visually. So that's what we're going to do right now. So the formula is 2 times width times length plus 2 times height times length plus 2 times height times width. Now, if you're anything like me, when you first see that, the mind starts racing as to, where's the width, where's the height, and so forth. This is a rectangular prism broken down. I've put this in base, the top. So if you were to fold these sides up, this top flap would rest or sit above here. So essentially what we have is 3 pairs of identical rectangles. And it might be obvious from the eye right now without any numeric values, but there are 3 pairs, and that's why I've done them in 3 different colors of identical triangles. And we're going to talk about where the width and length is of each of these and which ones are identical. So for the color coordination, for our first bit, 2 times width times length. The reason why we do it by 2 is because there's a pair, right? There's 2 of them. Length times width times length, is the probably the formula that we're most familiar with, and that's to solve for a rectangle. So you've got the width here, the shorter side, and the length. So if you were to multiply the length by the width, you would solve the area for this rectangle, and by multiplying it by 2, you get the area for both. The second pair that I'm going to do, I guess I'm doing this a little backwards, is the blue ones here, which is 2 that we're using the height because remember, if we fold these sides up, this is the height of the rectangle by the width, right? And the width is exactly the same as the width on our first pair. They share the same line segment. And there's 2 of them, so we multiply by 2. And then lastly, the orange ones are my height times length. So again, it shares that length from our first pair, and it has the same height, and there are 2 of them. So that's why the formula looks the way it does. The reason why we split them up into 3 pairs of identical rectangles is for the fact that you can see that this rectangle has a different base in the top dimensionally than the side lengths. Some rectangles are all even. You might have 4 that are equal, but this is just kind of the more universal and foolproof method for doing it. So again, we need bed mass to solve it properly. So we're going to move it in here with some numeric values assigned to the width, length, and height. And again, you can see which sides are the same. Of course, our length is going to be 14. You can see that across the board here. Our height, the 3 lines here, is 4. So you can see the height is 4. And our width is 6. So again, we need to use bed mass. This one's actually fairly straightforward, and you'll see why in a second. You're just essentially plugging in the numbers and adding them all up at the end. So first things first is I insert the numbers. So on my green rectangles, on my base and my top, which is the 2 times width times length, okay, width times length. So it's 2 times 6 times 14, because 6 by 14 is the area of this rectangle, multiplied by 2 to get both. The second is our orange, didn't do it backwards this time. Those are our sides. So we've got 2, because there's 2 of them, height by length. Remember, the length is 14. And then lastly, we've got these little, the other sides, the smaller rectangles, and that's 2, because there's 2 of them, times height times width. We know the height is 4, it's the same as this one, and the width is 6, so it's 2 times 4 times 6. Now, I've put them in brackets again to separate them because we want to solve each pair of rectangles before we add them up, because in bed mass, you have to do all of your multiplication before you get to addition. So 2 times 6 times 14 is 168. 2 times 4 times 14 is 112. 2 times 4 times 6 is 48. So we complete each bracket. And lastly, we add them all up. Usually I'm a fan of doing these step by step. You can certainly do that. You could do one line where it's just 168 plus 112, and then your next line is that answer plus 48. For me, I just put them all in for the sake of simplifying it for this video. So if we add them all together, we're left with 328 centimeters squared. So again, the reason why we like breaking them up into nets, or at least the reason why I like to do them, is it reminds me of, like, it takes that 3D shape and it brings it back to a 2D format, which hopefully allows you to see why these formulas are put together the way they are and why they make sense. Eventually we'll move this to giving you a 3D shape, and you'll have to, identify the width, the length, and the height just using the formula. But it's a good idea at first to see exactly why these formulas are designed the way they are, and we're not just plugging in numbers for the sake of that we can plug in numbers and solve expressions.